All right, Chapter 7, Section 5, Properties of Trapezoids and Kites. We're finishing the last remaining two for quadrilaterals for this chapter. We did special parallelograms, which were squares, rectangles, and rhombuses. Trapezoids and kites do not have the same properties, nor do they have the same properties of parallelograms, so do not get those mixed up. Trapezoids, this is vocabulary that we should know. If not, hopefully you remember it today. Looking at the first thing, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, there's only one pair of parallel sides, and the parallel sides are called your bases. Think of the base on the ground. It is flat. It is what you stand on. Those are my parallel sides. The non-parallel sides are called your legs, okay? Base angles of a trapezoid are two consecutive angles whose common side is a base. So if you're wondering what does that mean, where are my consecutive angles? If you're looking at it, your consecutive angles, these angles are consecutive, and these angles are consecutive. If you forgot what consecutive means, it means if I add those two angles, they're going to equal 180, okay? All right, isosceles trapezoid. We've dealt with an isosceles already, but looking at an isosceles trapezoid, it's a trapezoid with two congruent legs, okay? So if I'm looking at it, here is my isosceles trapezoid. What makes it isosceles is that my legs are congruent. All right, covering our theorems. They did not write the name of the theorem, so we're going to go ahead and write it on there. Looking at the first one, if a trapezoid is isosceles, then each pair of base angles is congruent. So when you're looking at this one, this is isosceles trapezoid base angles theorem. Okay, again, if a trapezoid is an isosceles, so we're going from if a trapezoid is an isosceles to, then each pair of base angles is congruent. Now look at the next one. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. What do you think that one's going to be? Look at the statements. What do you think the second one's going to be? Yes.
It's going to be converse of the first one.
Good. It's going to be converse of the first one. So it's isosceles trapezoid base angles converse. Okay, the second one is the converse. So looking at the first one, each pair of base angles is congruent. Please do not forget that. You have to know which angles are going to be congruent. So my base angles, this is a base. This is a base, this is a base, and these are my base angles. So keep in mind which ones are congruent. Looking at the last one, it says a trapezoid is isosceles if and only if its diagonals are congruent. So this is going to be isosceles trapezoid diagonals theorem. Okay, isosceles trapezoid diagonals theorem. And again, that means your diagonals are congruent. Okay, so pay attention to how I drew my congruent marks. My diagonals are congruent. Keep in mind it does not bisect and it's not perpendicular, so do not get that mixed up. Your diagonals are going to be congruent, and that's it. All right, mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the legs. So we should know what midpoint is. If you don't remember what midpoint is, You're adding your two x's, dividing it by 2, and then you're adding your two y's, dividing it by 2 to find the midpoint. But this is just looking at my mid-segment. So for this, I'm working with my bases. So if you look at the next slide, the formula, they're giving it to you as half times. I like to write it as either half times base 1 plus base 2, or most of the time you will see me write it as base 1 plus base 2 divided by 2. Does it matter the order of my bases? No, it does not. So again, what are my bases? They're the parallel lines. So this red one and this green one, you're adding those two and then dividing it by 2 to find your mid-segment. Mid-segment is this right here in green. All right, looking at kites. A kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So looking at my kite, which sides are congruent? These sides are congruent, as well as these. Again, do not get these mixed up with parallelograms. Where opposite sides are congruent, these are not opposite sides. Okay, these are not opposite sides. All right, theorems, properties for kites. What do we have to know about kites? With kites, your diagonals are 90 degrees. Okay, diagonals are 90 degrees. So if you want to draw those in there, your diagonals intersect at a 90-degree angle. And something else that you have to know, there's only one pair of congruent angles. And does it matter the pair? Yes, it does. 100% it matters the pair. Okay, for quadrilaterals, the kite, then exactly one pair of opposite angles are congruent. It does matter the angles. So if I were to draw a kite, okay, we know that these are congruent. If I were to draw a kite and they were to ask, is this angle congruent to this angle? Are they opposite angles? Yeah, but are they congruent? This would be no. This is not congruent. Okay, these are not congruent. What has to be congruent? It has to be the two angles where the non-congruent segments meet. Okay, so just be aware of that. It does matter which angles are congruent in a kite. Looking at example number 1, they want me to find the measure of angle A. Keep in mind, we have to know what's congruent in a trapezoid. Okay, what angle is congruent to C? What was it? What angle is congruent to angle C? Angle C is 100. Which one's congruent to angle C? Angle D. Okay, so this is also 100 degrees. And then what else do I know? What do I know about angle A and angle D? What are they? Good, they're consecutive angles. Please do not forget that. So I'm just going to write here my consecutive angles. Angle B plus angle C is going to equal 180. Those are consecutive. And angle A plus angle D is going to equal 180. And just writing it so we have it, those are consecutive. Okay, those are consecutive angles. So all I have to do to find the measure of angle A is subtract 100 from 180. Do you have to do all this work? No, you don't have to, but I'm just showing you how it is thought about. So angle A is 80 degrees. Okay, questions on this one? Are there other ways of finding the answer? Yes. So if you look at the second example, I'll do it both ways, depending on which one you want, because I know last class someone else told me a different way. But looking at this, what is also congruent to angle H? angle E. So this is also 49. Okay, and they're asking us to find the measure of angle F. How would I find the measure of angle F? How would I find the measure of angle F? Yeah. Good. Subtract it from 180. So we know that the measure of angle F plus angle E is going to equal 180. How do I know they're consecutive? So all I have to do is plug in. I have 49 plus the measure of angle F equals 180. Subtract 49. And the measure of angle F is going to equal 131. However, showing you another way how to do it. How to solve for the measure of angle F. I know the interior measure of a quadrilateral. What's the interior measure of a quadrilateral? 360, good. So if the entire inside equals 360, I can go ahead and find what's missing. So I'm going to add 49 plus 49, that's going to give me 98. Then I'm going to subtract it, 360 minus 98. I'm going to get 262. Keep in mind, these two angles added together are going to equal 262, and they're congruent. So all I have to do is take that 262 and divide it by 2. So this is going to give me 131. So now I found the measure of angle F, and the measure of angle G is going to be 131. All right, looking at example number 3, what are they giving me? They're giving me KB, which is 21.9. They're giving me MF is 32.7. They want me to find FB, which is right here. So labeling what I have, 21.9, 32.7, and FB. So if I'm looking at it, how would I solve for FB? Keep in mind you have to understand that your diagonals are congruent. So how would I solve this?
Since MB is going to be 21.9, we subtract 21.9 from 32.7.
Good. All you're doing is subtracting. Yeah, because this segment here is also going to be 21.9. So you have to find what's left over. So you have 32.7 minus 21.9. If you subtracted correctly, your answer should have been 10.8. So this segment is 10.8. All right, looking at example number 4, we're dealing with a kite. Let's go ahead and label what they're giving me. The measure of DAB. Okay, DAB right here. This entire thing is going to be 54 degrees. And looking at the next one, they're giving me the measure of CDF. CDF is 52 degrees. They want me to find BCD. There are a few ways you can solve this. Okay, look at it, think about it. How would we solve this? Does anybody have an idea of how we could solve this? All right, keep in mind when you're giving shapes like this, you have multiple triangles in there. So you could look at it as a triangle. Sophia, how would you?
No, I just did it wrong.
Okay, does anybody else have an idea of how they would solve this? Okay, how I would solve it is I don't necessarily have to fill in everything for my kite. I don't want to have to do that because that's going to be a lot. So I'm looking at it as if this is a triangle right here. This is an isosceles triangle. How do I know it's isosceles? Because I know which segments are congruent in kites. These segments are congruent, and these segments are congruent. So right now I have an isosceles triangle. This angle is 52 degrees. So that means this angle is also 52 degrees. How would I find what's missing? Good. I'm going to have to add both sides. I'm going to get 104 and 180 minus 104. That's going to give me 76 left over. So this angle is going to equal 76. All right, could you have looked at a different triangle? Yeah, you could have looked at this triangle as well. How do I know this angle? Because the diagonals of your kites intersect perpendicularly. So I know that that's going to be 90 degrees. Then I would have 90 and 56 would give me this half. And then these two are going to be congruent. So there's quite a few ways you can look at this and solve this depending on what's given. So you can look at it using triangles, and keep in mind the measure of the interior of a triangle is only 180. All right, looking at the last slide, we're dealing with mid-segment. So always remember the rule or formula for mid-segment. You're going to have base 1 plus base 2 divided by 2. That's how I like to write it. This is again my mid-segment, not my midpoint. So it says find the length of the mid-segment of the trapezoid. What two numbers am I going to be adding? What are my bases? Good. Does it matter which one goes first? No, it doesn't matter. So I'm going to put 18 plus 10. I'm going to divide it by 2. I'm going to get 28 over 2. If you simplify it, that's going to give you 14. So I know the measure of the mid-segment, MN, is going to be 14. Just look at your answer to make sure it is reasonable. Is 14 in between 18 and 10? Yes, so I know it's going to be correct. If you're getting some super large number or super small number, just double check it, make sure it makes sense. All right, and looking at the next one, find the length of AB. Now they're not giving me my base. They're not giving me one of my bases, so I'm still going to plug it in that way. I'm going to have 11.5 plus, I don't know my second base, divided by 2 equals 18.7. So solving for x, what do I do first? Okay, multiply both sides by 2 to get rid of that divided by 2. So I'm going to get 11.5 plus x equals multiplying 31.4. And then what should I do? Good, subtract by 11.5. If you subtracted correctly, what would your answer be? 25.9. $37? Is that what it is? 37.4? Oh, then I wrote it wrong. Okay. 37.4. So let me change this. 37.4. And then let me fix that 5. And then, was it still, did I still get the right answer? I probably just wrote it wrong. What is it?
It's 25.9 because you wrote.
It is 25.9.
You wrote 37.5.
Okay. 37.4.
Yeah.
Oh my goodness. 37.4. All right, so it's still 25.9. All right, questions on these?